Hello, class. So this is a recorded lecture for section 3.2. I think we'll be able to do this in one recording. So the two main subject matters is talking about how to decide if an equation is a function or not. Best way to do that is to graph it. And then we're going to talk about graphs and all the attributes of the graphs that we know up to date and how to calculate all those. So the first thing we want to do is talk about some equations and how to decide if it's a function or not. And you do that with what's called the vertical line test. And so the idea of the vertical line test allows you to look at it visually. And the concept is that if you take and draw a vertical line after you graph an equation, and if the vertical line passes through more than one point, it means it's not a function. That means that at that point, you have possible vertical line connection, and the aspect of a non-defined instantaneous slope can occur. And so that's what we're trying to decide. And the best thing to do is to graph it and look at it via the vertical line. And as I mentioned, I think before, Desmos is a really good tool that will graph these equations for you. So I'm not going to ask you to graph these, but just pull up the Desmos and type in a few equations. So let's take a look at a few of them. And so let's start with the linear equation, y equals 3x plus 5. So you sure do hope that this is a function, right? And you could see in this case, it's a nice straight line. And if you zoomed out, you'd see it just goes on to infinity. And if you cross any one of these, you would see that the vertical line only passes through a single point. So this would be a good example of a function. Say like we take quadratic, which we sure do hope is a function, right? Plus 6x, say plus 9. And so you could see that this graph looks like this. It looks like a U. And we're going to talk about how to graph these in chapter 4. But you see that if you take the vertical line test and you try to take this graph and pass it through more than one point, again, it doesn't work. And so you would see that this is also a function. Well, let me show you a couple that aren't a function. So instead of x squared, I've made y squared in this case. And you can see that this is a quadratic that actually opens up to the right. And if you take vertical line, right, and you pass through it, like right here at 100, you see it passes through this point and that point. And so here is an example where this is not a function. Let's see, let's do one more. How about if we do a circle? So x squared plus y squared plus 6. Oh, that's not quite a circle. So this is y squared equals x squared plus 6, just another equation to show you. You could see it's a parabola that opens up and down. And so in this case, definitely not a function because you can draw a vertical line and every vertical line passes through 2 points. So that one's definitely not a function. And so let's do a circle. I had my circle equation wrong. So if I just redo this real quick. There we go. So there's an example of a circle. And I could zoom in a little bit better, and you can see that the circle has a center at the origin. And the radius is square root of 40. I can make a better, nicer number. And so that radius, square root of 36 would be 6. But you can see that what we're talking about with regards to this aspect of it is this a function or not? And again, obviously it isn't, because if you draw a vertical line, you would see it would pass through 2 points and all conditions except at the 2 and 0, 6 and 0, and minus 6. So my message to you all, and with regards to evaluating if an equation's a function, is pull up the program like this or this program, type in the equation, see what the graph looks like, and do the vertical line test. Best way to find out if an equation is a function is to graph it in vertical line test. The algebra could be super complicated, so we're not going to go over that. So the other part of this section is to talk about if you have a graph, and I've done this graph getting ready for the lecture, and answer a bunch of questions about the graph. And so let's walk through each one of them and see what we know about it. So for example, the first question are, what are the x-intercepts? Well, that's where the graph touches or crosses the x-axis, and it looks like we have 3 of them. This point here would be -3, 0. This point here is, that should be a minus, sorry, -1, 0. And then this last point here is 1, 0. So we have 3 x-intercepts. What about the y-intercept? Well, we only have 1. If you had 2 y-intercepts, it won't be a function because of the vertical line test. So this would be 0, 2. So if you look at this, you can see again, using the vertical line test, that this graph is a function. And if you did the vertical line test, you would see that every vertical line would only pass through 1 point or 0 points. If you go farther on, I have this backwards as well. Sorry about that. This should be x is 4 and y is -5. I had that backwards. So next question. Say like I asked you, what is f of 0? So basically this value here is the x value. So the x value is 0 is right here. And what would the y value be? 2. So you see how you read with regards to being able to calculate this? So what would be, say, f of 1? So that would be x is 1, so y equals 0. Last one, what would be, say, f of 4? So here, x is 4, so y would equal -5. So see how to evaluate it? If I asked you what f of 6 was, you can see that's not defined. So it would be undefined here, because you could see that when we get, let's say 5 and that's 6, you could see that there's no y value associated with that. And so that would be undefined. Next question. Oops. The eraser out here. Next question would be, what is the domain? And so how do we do that? Well, it's really nice if you have a graph. It's much nicer because you can visually see what the domain is. So the domain is all the x values that are defined by this graph. So you should look for what's the smallest x value and then what's the largest x value. So if you go all the way to the left, right, that's the smallest x value. What this arrow implies is that we're going all the way to -infinity. So the x starts at -infinity, and then you kind of walk your way positive. So you're coming up and you're getting and it's positive, you get to the origin, everything's cool, right? So that's x equals 0. And you keep going, and it looks like the graph stops at x equals 4. And then you look at this and say, okay, there's a dot there, right? A closed-in circle. So that means that it is included. And so we end up putting a bracket. So by convention, again, the first number is the most negative and the second number is the most positive. What about a range? Well, to calculate a range, just like if you're given an equation, just like I said, when you calculate the, if an equation is a function, the best way is to graph it. Same thing with the range. Graph the equation or look at the graph like we have. And again, you're looking at the extremes of the y. Now, range is y value. So what is the smallest y value and what is the largest y value? Well, the smallest y value looks like it's -5, right? So we go down here, that would be -5. And again, since that's a closed circle, we use the parentheses because it's included. And what do we do here? Well, if we go up, 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 this arrow means we're going all the way to positive infinity in the y direction, right? And so that would be positive infinity. Again, infinity is not a real number. And so with regards to that, you put a parentheses in there. So let's talk about maybe one more thing. What if you're asked the question, what are the values f of x would be, say, greater than 0? How would you think about solving something like that? Well, that one is interesting with regard to that, because if you think about that solution, we need to think about what values are going to be greater than 0. And so the idea is, remember, the 0 point for the y value now, right, is right here on the x-axis. So what you want to do is you want to find all the parts of the graph that are above the x-axis. If this was less than 0, then it would be all the parts that were below the x-axis. So this one's a little bit tricky, and because there's no equal sign here, these points are not included, the ones that are touching. So the best way I like to do this is to kind of split it up into the different sections. And so this first section here, right, is above the x-axis. So that would be from -infinity all the way into, we get to x equals -3. All right, so this line, the domain of that is defined as -infinity all the way down to -3. And the reason why the parentheses is here is that there's no equal sign here, so that dot is not included with regards to that. So this is below the x-axis, so we don't want to include that. But then once we get to -1, from -1 to x equals +1, again, we're above the x-axis. So that would be, we'll put a little union there. And again, because the x-axis is not included, it would end up being -1, whoops, excuse me, not to 0, it goes all the way to x equals +1. And then the rest of the graph is below the x-axis, so we don't have to worry about that. And if you were asked for less than 0, you would just take the other parts of that as well. So this concludes section 3.2. There is one other parts of this section that should be in 3.3, and there's a couple questions that talks about symmetry, and I am going to talk about symmetry in the next recorded lecture. first part of 3.3, which talks about odd and even functions. So you might want to take a look at that before you delve into this section of